Another day, another story. The determination of particle size distribution by sieving, also known as grain size analysis, is a common method used in geotechnical engineering and soil testing. It involves separating and classifying soil particles based on their sizes using a series of sieves with different mesh sizes. This method provides valuable information about the gradation of soil, which is essential for various engineering calculations and soil classification. Equipments required: A. Sieves of sizes 4.75 mm, 2.0 mm, 1.0 mm, 600, 300, 150 and 75. That is, IS 460-1962 is used. The sieves for soil tests 4.75 mm to 75 microns. B. Thermostatically controlled oven. C. Trays, sieve brushes, mortar with a rubber-covered pestle, etc. D. Mechanical sieve shaker. Procedures: A. Take a representative sample of soil received from the field and dry it in the oven. B. Use a known mass of dried soil with all the grains properly separated out. The maximum mass of soil taken for analysis may not exceed 500 grams. C. Prepare a stack of sieves. Set the sieves one over the other within ascending order. Sieves having larger opening sizes, i.e., lower numbers, are placed above the one with smaller opening sizes, i.e., smaller numbers. The very last sieve is number 200, 75 mu sieve. A pan is attached to the lowest 75 mu sieve to collect the portions passing number 200 sieve and fit the nest to a mechanical shaker. D. Make sure sieves are clean. If many soil particles are stuck in the openings, try to poke them out using brush. E. The whole nest of sieves is given a horizontal shaking for 10 minutes in sieve shaker till the soil retained on each reaches a constant value. F. Determine mass of soil retained on each sieve including that collected in the pan below. Here is a step-by-step procedure for determining the particle size distribution by sieving. 1. Apparatus and materials. Set of sieves. A series of sieves with different mesh sizes, typically including sieves with openings of 4.75 mm, 2 mm, 1 mm, half a millimeter, 0.25 mm, 0.125 mm, and a pan at the bottom to collect the finest particles. Sieve shaker, a mechanical device that agitates the sieves to aid in the separation of particles. Balance, a sensitive balance capable of measuring weights accurately. Oven, used to dry the soil samples. Cleaning brushes, used to clean the sieves. Containers, used to collect and store the separated soil fractions. 2. Sample preparation. Collect a representative soil sample from the desired depth. Ensure that the sample is free from organic matter, roots, and debris. If the soil contains large particles, use sieves or manually break down the aggregates to obtain a representative portion that can pass through a 4.75 mm sieve. Thoroughly mix the soil sample to ensure uniformity. 3. Weighing the sieves. Weigh each sieve individually and record their weights. Ensure that the sieves are clean and free from any debris or soil particles. 4. Sieving process. Stack the sieves in decreasing order of mesh size, with the pan at the bottom. Place the soil sample on the top sieve, 4.75 mm, and cover it with a lid. Fix the sieves onto the sieve shaker and start the shaking process. Shake the sieves for a sufficient duration, typically 5 to 10 minutes, to ensure efficient separation of particles. After shaking, remove each sieve from the stack carefully, and brush off any retained soil particles into a container. Weigh the soil retained on each sieve accurately and record the weights. If necessary, repeat the sieving process with a fresh portion of the soil sample until the soil passing the finest sieve pan is negligible. 5. Calculation. Calculate the cumulative weight retained for each sieve by adding up the weights of soil retained on that sieve and all the sieves above it. Calculate the cumulative percentage retained for each sieve by dividing the cumulative weight retained by the initial weight of the soil sample and multiplying by 100. Calculate the percentage passing for each sieve by subtracting the cumulative percentage retained from 100. Prepare a grain size distribution curve by plotting the sieve sizes on the x-axis and the percentage passing on the y-axis. 6. Reporting. Record the sieve sizes and their corresponding percentage passing values in a tabular format. Include the grain size distribution curve in the report. If desired, calculate and report additional parameters such as the coefficient of uniformity, coefficient of curvature, and percentage of gravel, sand, silt, and clay fractions based on the grain size distribution. Graph. Grain size in versus percentage finer in percent. Draw graph of log sieve size versus percent finer. The graph is known as grading curve. Corresponding to 10%, 30% and 60% finer, obtain diameters from graph. These are D10, D30, D60. Using these obtain CC and Q, which further represent how well the soil is graded, i.e. whether the soil is well graded, gap graded or poly graded. Remember to clean and dry the sieves thoroughly after the experiment to maintain their accuracy and prolong their lifespan. Thanks for watching.